Okay guys, in this video we will actually understand this is actually pipelining. So we are going to understand pipeline. I have already told you in my previous classes about pipelining. That is, pipelining is where multiple instructions are simultaneously getting executed. That is what pipelining means. So that means the pipelining is basically divided into, you have to understand some things right now. That is, you have to understand that in pipelining what happens here is that the processor is divided into some stages. That is basically divided into 5 stages. So you have to understand the processor is divided into 5 stages. So when one instruction is there in one stage, the other instruction would be there in another stage. So there are basically, you have to understand that these are the different stages here. You have the fetch stage, you have the decode stage, you have the execute stage, the memory stage, write back stage. So if one instruction is in the fetch stage, another instruction would be in the decoding stage, another instruction would be there in the execute stage, then another instruction is the memory stage, and another instruction in the write back stage. So at a time 5 instructions can execute because there are 5 stages. So when such things come, what is the benefit? You can increase the throughput. Throughput means what? The number of instructions which is executed at a particular time. That is throughput, right? So when such, because of pipelining, what happens is that you can actually increase the throughput. Understood? So now I want to tell you that how we are going to learn this, how pipelining is actually implemented. So this is the basic diagram from our single cycle itself, but in that we are going to add some changes. How parallelly execution can occur, that is what we are going to understand from here. So first of all, why do we need pipelining? I already told you we need pipelining so that multiple instruction can occur at the same time. In single cycle processor, imagine you are doing laundry. So there are some stages: wash, dry, fold, put away. In a single cycle process, it's like wash one shirt completely, then you are going to put it, dry it, then you are going to fold it, then you are going to put it away. Then only we are going to start using next shirt, right? But in pipelining, while the shirt 1 is drying, we will start washing shirt 2. While shirt 1 is being folded, we will dry the shirt 2, like that. Understood? If one process is another stage, then the other process would be there in the stage before it. Understood? This is what exactly the use of what pipelining. Now I have already told you F, D, E, M, W are the different stages in pipelining. That is, F is the fetch stage, D is the decode stage, E is the execute stage, M is the memory stage, and W is the write back stage. Okay. If you consider the fetch stage means you are getting the instruction. The processor looks at the program counter, and the program counter is like the pointer which is actually reading that is fetch the instruction. Program counter would fetch the instruction from in the memory, and that instruction, fetching the instruction from the instruction memory, right? There is data memory, instruction memory. So instruction memory, from the instruction memory we will be fetching the instruction that what program counter do, then compute speed, then it will compute the next instruction by using PC+4, right? So read the memory is 100. First PC value would be 100, let's say. Then it will read the instruction. Then the PC would increment the value by PC+4. So the first fetch cycle is getting the instruction from the instruction memory, and you are getting the final instruction. That is what fetch is doing. Decoding means you are understanding the instruction, decoding the instruction, finding out what are the registers in it, who is the destination register, if there is immediate value. These are the things. And in the decoding itself, we are basically reading the value from the register file. Okay, and sign extends the immediate. If you know, this is decoding is dealing with taking the values from the register. If I wanted to write any value to the register, not right is not here, sorry, that's my bad. Here source registers values are readed, destination register, who is the destination register, that is find it out, and also the immediate value, that is also looked. Also if you want to extend it, extend the immediate value, that is also done in the decoding part. Overall, accessing the things from the registers and the immediate extending the immediate are the things that is happening in the decode. So these are the things which is happening in the decoding part. Now executing part is the ALU computation part, where you are adding, you are subtracting, right? And if you have to go to any branch target, then you have to do PC plus immediate, right? That is executing the if I want to go to branch, then I have to do that also. So I have to check the if zero flag and all, if it is zero flag, that is the executing part. Most of the things which is registers related is happening in the decode. Access in the register, who is the RD, immediate extender, all are happening in decode. The executing part is most of the ALU computation. If I wanted to find, if there is branch, I have to find PC plus immediate value. That is also computed in the execution part itself. Now we have the memory part. Memory part is like if I wanted to access anything, reading or writing in the memory, if I want to write anything to the memory, if I want to read anything from the memory, that part is the memory part. Then I have the write back part. Write back part means the last part, that is here. The value from the memory, if I wanted to store it in the register using a multiplexer, we do that, right? If I want to do that, save the value result to the register file, then that is I want to write the value in the RD, right? That is happening in the write back part. Okay, write back part. This much we have understood the different stages here. Now you have to understand that there are some pipeline registers in the hand of between each register there is a pipeline register. Between each stage there is a pipeline register present here. That is, if you see this diagram, these are the different stages. This is the first stage, a fetching stage, decoding stage, executing stage, memory stage, and write stage. That I will tell you. Between each of these stages, these are the are this rectangles. These rectangles are what? These rectangles are the pipeline registers. That you have to understand, these rectangles, right? These rectangles are the pipeline registers. Now guys, you have to understand, this is my fetch stage. Fine, this is my this part to this, right? This part is my decoding, some problems, okay, decoding stage. Now this to this part is my executing stage, and this to this is my memory stage, and this to this is my write back stage. This much we have to understand. Fine, okay. Now see here, so we have this pipeline registers in between them. Why are they needed? Each stage finishes in one clock cycle. The result must be held or saved before passing to the next stage. So without them, values would be lost. So why do we need these rectangle shapes in between them? That is, these pipeline registers between them. We have to understand that each of the stage is executing in one clock cycle. So in one clock cycle, each of the instruction would move away from that particular stage in which it is present right now. So one stage is completed in one clock cycle. That is what you have to understand. So we have to store the values or save them or held those values of each of these stages somewhere. That is why pipeline registers are used. If there is no pipeline registers, then these values will get lost. So in each clock cycle, stage F saves the result in the pipeline register 1, and stage D, that is the next stage. Fetch stage is the then decoding stage is the right. After fetch stage you have decoding. So decoding stage would read the value which is there in that pipeline register 1. Now next clock cycle, the stage D would save the result which happened in that stage. Then pipeline register 2 would save that value. So the next stage is what? Executing stage. So the executing stage can read them like that. That is what is basically happening here. Now naming conventions here. Signals get suffix letters showing which stage they are in. Now PCF means PC is in fetch stage. PCD means PC is in decoding stage. PCE means PC is in executing stage. ALU result means ALU result in the memory stage. ALU result go to the memory. Whatever the result is in the ALU, that is going into the memory stage. Result W means the final result is there in the write back stage, has gone to the write back stage. So you have ALU result M, that is ALU result is in the memory. Then result W means the final result is going to the write back stage. Then PCF, PCD, PCE. PC is in the fetch stage, PC is in the decoding stage, PC is there in the executing stage. These are the things you have to understand. This much you have understood. Now let's understand the next thing. That is, how do multiple instructions follow the order? First, instruction 1 would be in the fetch stage. When it is completed the fetch stage and go to the decoding stage, then instruction 2 would be in the fetch stage. Then in the next clock cycle, the instruction 1 would be from the decoding stage go to the executing stage. So instruction 2 would go to the decoding stage. So therefore the instruction 3 can come into the fetch stage. In the next clock cycle, the instruction 1 would go to the memory stage. So instruction 2 can go to the execution stage. So instruction 3 can go to the decoding stage. So instruction 4 would come into the fetch stage, like this. So 5 instructions are executed in 5 clock cycles. So 25 cycles are needed, right? 25 cycles are there. 5, in single cycle what happened is that 5 instruction requires 5 clock cycle. So 25 cycle. But in pipeline, 5 instructions are using only 9 clock cycle. That means the first instruction uses, see, 1 clock cycle what happened, 1, 2, 3, 1 clock cycle, only 1 instruction, 1 thing only is happening here. Okay, in the next clock cycle, 1, 2, 3. So here you have to understand, within the 5 clock cycle, this is completed, right? Here extra 1 clock cycle is needed, 5, 6, 7, 8, 9, extra 1 clock cycle. Here 5 clock cycle. Within 5 clock cycle, these much things happened. Sorry, not within the 5 clock cycle. Within 5 clock cycle, for this happened, for this the first this much happened, right? Then you have to understand 9 cycles is only needed. So first 5 clocks, first cycle is this. In this cycle, this would occur like that. So if you see, for one instruction requires 5 cycles in single cycle. So if there is 5 instruction and each of them require 5 cycles, 25 cycles are needed. But if you see here, let's see, for this instruction how many cycles are needed? 5 cycles are needed. But this instructions already is done. One fetch is already done in one of this instruction, and this also is done, this also is done, this also is done. Now we need extra write. Only last one cycle is only needed, 5 plus 4. that is 9 cycles are only needed for pipeline. You have understood that. So there is one problem, that is RD problem. Let us understand what is this RD problem means. What needs to happen in the write back? See, to write a result to the register file, the value to write, that is result W, which register to write to is RD. Where you want to write is RD, and the value that you have to write is result W. Let us say instruction enters the fetch stage, instruction is in the decode, RD is read here, instruction execute, instruction write back, so result W is ready here. Now RD is from cycle 2 and result W is from cycle 5. Meanwhile in cycle 5 new instruction is in decode with its own RD. See, they both are in different 2 cycles, right? See, if you see here, instruction 1 wants to write to the value to x2. So 4 cycles later, instruction 5 is instruction 5's RD is x17. Okay, that is in decoding state. Result of LW gets returned to x17 instead of x2 because instruction 5, what happens is that let's say here x17 is now in the RD. So what happened is that when you are doing the instruction 5 in this stage 5 in here, in this load, the value of this instruction, that is the what you are going to write here, would be returned to S17 and not to S2. That is a problem which is going to happen here. Understood? So that problem is going to come here. 1 minute. So if you see here, PCF is the PC fetch. This is what PC fetch thing. These are all PC fetch. Fine. Then instruction D means INSTR. D means the instruction is coming from the instruction. This is PC plus 4F is in the fetch stage itself. This is fetch stage itself. Fine. Till this much it's all fetch stage. PC F is in fetch stage. PC nest. PC value nest should also go here. Right. And also PC target. This is an executing stage value also goes here. So PC F nest. PC plus 4F is also there. Now instruction coming from here is instruction D, that is in the decoding stage, that you have to understand. It is in the decoding stage. Now it can also go to extent, immediate extent, which is there in the decoding stage, can be there. And also RD. RDD means that RD is the decoding stage RD value, that is there in the decoding stage. Now if I wanted to calculate here, from here the store value, that is the PCD current instruction, I needed to add it in this adder to get the next PC target E, that is coming in the executing stage. Now RDD, I have to store the RD value here in this register, then only I can go and do it in the 5th register. So the thing is that RDD value here I will be storing in this pipeline register. Now RD1E and so here RD1 and RD2 value is stored, and RDD value is also stored, and PCD value is also stored. Then what else is stored? PC plus 4D value is also stored in here. Now PC plus 4D value plus 4 PC plus 4 value is stored. Why? That we will discuss why we have to do that. Fine. Now we have understood the RD1E and RD2E is going here in the source AE and source BE, RD2E. Now the result, ALU result can go here. Now we have this write data E and write data M. Now what is write data? That means here, if I wanted to write the data which is present in this RD2, that is, if I want to write the data which is present in RD2 the data memory, that is store case. If I want to do the store case, then I have to store that value in this register, right? Then only I can write it in the data memory. Understood? Now ALU result, maybe I can go directly to the multiplexer to read it here, result W, or maybe the value which is in RD, read data W, the data which I have read from here, that I can go and write it here. That is the thing that I'm going to do, right? Now why PC? In order to make sure that, now there is 0 0 0 1 1 0, in order to make sure that there is no bug which is going to happen, that is why we are PC plus 4D, PC plus 4E, that value you are going to pass the multiplexer directly. So the thing that you have to understand, that in each of this register, PC plus 4 value is stored in each of the stages registers, and and if you see here, in this register only the instruction is stored, that instruction is passed here. Now in this register, that is in this pipeline register, the value of RD1 and RD2 is stored, and also RD in the decoding stage, RD is also stored here. Now I told you, in the executing stage, the extending is also coming here, immediate extend is also coming here, that immediate extend value is also stored here. These are the things which is happening in the decoding stage. Now in the executing stage, that is this stage, this values can be calculated, or sometimes this value can be directly stored. So write data to the memory, that is, this can also be stored here. So this value can also be stored separately, or ALU result can be taken to consideration also. That case is also there. Read data W. Now this RD means here write data is the, read data is the, that maybe this RD value if you're taking means we are just reading the data, and result W is also there. Result W is also there. That is to store the value back to the register file. Understood? Now in this part also I told you we will calculate the branch thing, that is PCE, that is a current instruction, therefore we will be PC is already stored here. So from here the PC, that is a current instruction, will store in this register, that we will store in this register, then only it can be stored in here. And also PC plus immediate value is also needed, so that immediate value you have stored in this register has to be stored here also. This much we have understood. Then the PC target E will be going here. Understood? Now see RD, the destination register, here you are storing. Now RD also we are storing here, RD value is storing here also. Now if I want to write something, then RDW will be stored here directly. So now RD value separately stored here, RD stored here, here. Now if I wanted to write that data, RD is coming from the destination register. RD is what? In that instruction, that instruction's RD value should be stored everywhere. Then only you can able to store write that in here. WD3 will write the result, that is fine, but the address here, RD value, how you write it is, we don't directly write it here. What we do is that we don't write A3 directly here, we store it here, and if result W is needed, then RDW value, that is from this write back, that then only because there is a bug, we cannot directly put the RD value in A3. No, we don't do it first. We just store the value first in this then this, then this. When we need to read, then we will take the value and put it in A3. That is what we are basically doing. Okay, so you will be able to understand this clearly only when you know single cycle very neatly. So I want you to understand the videos which is there before, then only you will be understanding this. Then if you have any doubt, please write in the comment section. Thank you.